Okay, today's problem is all paths from source to target. So the question statement is given a directed acyclic graph, DAG of n nodes labeled from 0 to n minus 1. Find all the possible paths from node 0 to node n minus 1 and return them in any order. The graph is given as follows. Graph of I is a list of all nodes you can visit from node I. That is, there is a directed edge from node I to node graph of ij. So actually here we have been provided with the adjacency list, so we do not need to create one. That is a very important point here. And also that we have been given a directed acyclic graph. That means we do the directed acyclic, by directed acyclic graph we mean we do not have any self loop or a loop in this graph. So it is already in the topological order, so we do not need to carry a visited array as well here. So that was two of the most important point from this question, and we'll be solving this by using DFS. I'll just draw the tree here so it's easy to understand what we are doing in the DFS. So I'll just draw the tree here. So this is our question. It is 0, 1, 2 and 3. So we have here, I'll just add one more node here. So let's say we have something like 4 here. This is 4. Okay, this doesn't look like 4, but just consider this is 4. Okay, this is 4 here, and this is having an edge between 4 and 3. So we first of all start from here, that is 0. So we start from 0. I say that okay, I have a 0 node here. After that, I'll make a DFS call for 1 or 2, any of them. So let's say we are making a call for 1. So we will make a call for 1. Now I can make a call again for either 3 or 4. So let's say I'm going to make a call for 4. I can also make a call for 3. It depends. Whatever. I'm choosing 4 here so that it's easy to understand. And after that, I'm going to make a call for 3. And in the question, it has been stated that we just have to find for n minus 1. So if we reach n minus 1, we just go back. That is, we just found 3 here. So now we'll go back. That means we have got a path from 0 to 3 as one of my answers. So I'll just include this in my answer array and store it in a vector. So this will be one of the possible answers. After that, I'll just backtrack. So I'll go to 4 and I'll check, is there any other path that I can take to reach 3? And there isn't any path that I can take. So again, I'll go to 1, backtrack. So and now I'm at 1. Now I'll see, do I have any other option apart from 4? Since 4 has already been visited, I've already taken that path in there. So I'll go by taking the path 3 here. So from here, no call was made, no call was made. Now from 1, we'll go to what? 3. So as we can see here, we have got another part, that is 0, 1 and 3. So now we'll include this in my answer array. That is one of my possible answers. Now again, when I'm done with this is my n, so we'll return. So we will return to 1. Again, we'll check, is there any other path? No. So now I'll return to 0 here. So from 0, I'll say, can I take any other path apart from 1? And that is 2 here. So now I'll say, I want another path so as to reach to the final. So I'll say, I'll take 3 here. And yes, I do reach the final n minus 1 node, which will be one of my path, that is 0, 2 and 3. So now this will be added to my answer. Now I'll say, go, backtrack. Again, I'll reach to 2. Now I'll see that do I have any other part apart from this, the 3 path that I took previously to reach 3. So there isn't any path. So what will I do? I'll say backtrack and go to the node. And as I reach this, I'll be reaching till the end of the array. and I'll be finishing all the adjacency list matrix or the adjacency list simply, and we'll just return whatever paths we have got in our vector or vector int answer. And if you are using Java, you can just use a list of integers, and that's it. This is the main recursion tree that we can actually use off, and you'll pretty much get it how it's done. So let's see the code now, which is pretty simple. You just have to implement whatever we saw in the recursion tree there, and that is from here that I've taken a n, that is my target. Since we were told here it's here, from 0 to n minus 1 we need to travel and find a path. So first of all, why I'm storing this 0, I'll get to that point. But first of all, let's see what is happening here. We are making a DFS call here. 0 graph n and to store is a temporary vector of int which will be storing my current path which I'm traveling for. So now let's get to the DFS part, that is here, and I've declared this globally just to just to avoid the many recursion calls by passing answer, which will be getting too uh, clumsy here. So that is why I declared this globally. And after that, I could also not use this here because this is already declared here globally. So this is your wish. You can also use this here or declare it globally. And if you're declaring it globally, let me just make this say private, because this is just accessible to this class here, all the member functions here. So now I go to the DFS, I'll just check if I is equals to n minus 1. So have I reached the last position here, which was, okay, this is not visible, so I'll just release this tab and show this diagram again. That is from here. So have I reached this 3 point here? This is what this I is equals to n minus 1 is saying to me. This is what the n minus 1 is saying to me, this line here. So I'll say, have I reached this? Not yet. So what will I do? I'll just move on to the next part. I'll just move on to the next part, that is, okay, get to the description. After that, let me just sorry for that. Okay, so we have got here, so this condition was not fulfilled. Condition was not fulfilled, so we go to the loop for traveling to the adjacency list, traveling the adjacency list. After that, I'll go there. Okay, there is some problem here. Yeah, so we are here for auto IT in graph of I. So we are traveling in the adjacency list, and we are just simply storing all the possible directions that I can take to reach the n minus 1 node. That is what I'm doing here. After that, I'm making a DFS call, and I'm just backtracking here to store dot pop back, and that will be it. So I'll just run this and show you. Okay, I just missed a point as to why did I take graph 0 there. Why did I insert this here? Why did I insert this here? I missed this point. The reason why I inserted this is because I am traveling in my graph. In my graph, when I start the traversal, I'll be starting from what? I'll be starting from this one here. We do not have this 0 here. So we actually need to insert this 0 here into my to store, so as to travel from the 0th index. If it would have been given that I need to just start from 1, and I could have just done it from auto of IT, then it would have been given me the correct answer. But since we are just starting from 0th index, so we need to give 0 here. And there is another option also, there is another solution also in which we do not have to do that, and that is a pretty beautiful solution. Okay, I have also written that solution here, which is very elegant one. And we can also do this. If you want, you can just check it out, and I'll just submit this and show it to you. It's working fine. So that is why I was taking to store dot pushback 0, and this is getting submitted. And yes, that is it for today.